I will leave it for you to review the basics of polar graphs and polar coordinates, which you clearly studied both in trigonometry and pre-calculus. Now, what I will do today is talk about extending what we do know about polar graphs and talk about three tools of calculus. Number one, slopes, tangent lines. Number two, area. And number three, arc length given a curve described polarwise. Now, take a peek at how really, I'm not going to say anything new today. Technically speaking, if x and y are represented as such using polar coordinates, notice that it is the case that r itself is a function of theta. So technically speaking, everything on the right-hand side of both these two equations are expressed in terms of a single parameter theta. And so this is just an example of a specific type of parametric curve. So the first thing I want to discuss is slopes of tangent lines. So knowing what we know about parametric curves, I do think the slope of the tangent line to the graph of a polar situation can be expressed as such. It's just that this time around, I'm using the parameter theta instead of t. Doesn't make any difference, it's just a dummy variable. However, notice what this really looks like. Because technically speaking, if r is a function of theta, then to differentiate x respect to theta, I have to use a product. Same thing down here. So for differentiating y respect to theta, I get the root of the first times the second as is don't touch, plus the first as is don't touch times the root of the second. Downstairs, to differentiate x respect to this parameter theta, same idea. Root of the first times the second as is don't touch, plus the second times the root of the first. I think I said it backwards. Plus the first don't touch times the root of the second, but that would be a negative sign of theta. That being the case, on a polar graph, to determine whether or not my tangent line is vertical, I will see if this thing is undefined, I think. To see where tangent line is horizontal, I'll see where this thing is equal to 0, I think. I say I think because technically speaking, if both the numerator and denominator are 0 for the same value of theta, it will mean you basically have a cusp on the graph. And I guess I could say sometimes you'll have a corner point, but a similar idea. All right, let's jump into some examples.